Hello, and welcome to Physical Geography. I'm Jason LaBrosse, your instructor, and this is the first of many video lectures this semester we're going to be having. These video lectures are my PowerPoint presentations that I would normally be giving to you in class, and these are supplemental for your learning this semester. So they'll be broken up into shorter segments, usually about 10 minutes each, that you can watch one at a time on this video that I provided. So this first lecture is for the chapter GT, or Geographer's Toolkit. If I'm going to turn you all into geographers, and I'm going to do my best to do so, we need to discuss some of the tools that we use in geography. So first of all, welcome. But how many of you actually really think about what is physical geography? So this is the definition from the textbook. I always started with this way. Geography, if you look at the word geography, right? There's the word geo, which means earth, and then graphy, which means writing. So it's writing about the Earth. But physical geography, we study or we write about the Earth and spatial relationships, how things relate to each other spatially, their connection, their distance apart, their proximity together, how they interact, where we look at the physical features and the cultural features. So first of all, think about those terms. Spatial relationships. Are things close by? Are they far apart? Does one affect another? Does Do rocks roll downhill? That's spatial relationships. Physical features: lakes, rivers, oceans, forests, um, thunderstorms, right? Things that are quote unquote natural. And then cultural features: cities, farms, human made aspects. And these all interact. So physical geography studies the non living physical systems like hurricanes and thunderstorms and deserts and mountains, but how they interact with people. So, why do people live near the coast? One of the things that we'll talk about quite often is this idea of vulnerability. Some populations, some countries, suffer more from natural disasters. And it's not because the natural disasters are worse for them. The social structures that they have are not as well equipped. A good example is the island of Haiti or Puerto Rico, which experiences hurricanes every year. Hurricanes come through the Caribbean basin quite often, but they have a much more destructive impact in, say, Haiti or Puerto Rico than they do in Florida or Texas. And it's not because that they're stronger in Haiti, it's just that Haiti is a poorer country, does not have the same level of resources to protect themselves. And we'll get into the more details of that. That is physical geography. And so that is the overlap of human geography. So human geography talks about man-made structures, human issues. And to think about that in physical geography, if you look at the landscape outside, right? If you look out your window, do you see an anthropogenic landscape? In other words, is what you see outside your window right now, is it affected by man? Do you see buildings, streets? Do you see trees? Do you see fields? What do you see? Most landscapes are anthropogenic, and that's another word that you're going to hear until you're sick. Anthropogenic. So think about anthropology, the study of man. Anthropogenic landscapes are landscapes created by people. We make the land fit our needs. Chicago, until white settlers came in the 1800s, was mainly swamp and forest, which has all been cut down and drained, so that it's much more convenient for us. We cut down forests to grow crops, we dig rivers deeper for boats, we change the environment, right? And a lot of it is because we need natural goods. I apologize in advance for my lovely face here blocking this, but everything that we use, we eat, we drink, that we wear for clothing, that we use for computers, everything comes from natural goods originally from the earth, right? The clothes we wear come from cotton that is grown somewhere. The food we eat, as far as I know, and I've been checking, we are getting nothing from aliens. So everything comes from the earth. And so to take those materials from the earth, we inherently have to change the landscape. So here's an example. We have two landscapes here. View A is in Saskatchewan, Canada, and View B is New York City. I'm going to ask you to look at these two landscapes and then say which one do you think is natural and which one do you think is anthropogenic. So I'm going to sit here and pause and make silly faces while you think about that. before I answer the question. I could hum the Jeopardy theme, couldn't I? All right. Many people are going to say that A is natural and B is man-made. Because why do we say natural? Well, we see plants and a blue sky, and here we see buildings and concrete. And there is some truth to that. But this is not a completely natural landscape. This is wheat. This is the farmer growing wheat. Before this land was farmed, it was most likely wild grasses growing here. Wheat is a specific type of crop that is grown for food. So this is a completely man-made landscape. Not to say that this isn't, but if you look at this picture, this is a view of the Earth from space at night. And these bright lights you see, these are cities. And you can see that really, there's really not very many areas of the country that have not been touched by human cities. I mean, out west there's fewer. But if you take this view, if you think about the surface of the Earth, there really are very few areas that are not touched in some way by man's activities. And even if they may not have a city built in there, the air has been modified by all the pollution that we've dumped into it. Carbon dioxide has changed our climate. So in a lot of ways, there's really no place on Earth that isn't, to some extent, touched by humans. So to look at all these interactions, we look with different tools. And the first one is scales. Scales of inquiry. What are we looking at? How are we framing our investigation? And we can look at them spatially or temporally. Spatially or temporal. Well, spatially we talked about. We look at different sizes, and we'll get into that, or over time, because they give us different perspectives. So let's get right into this. A spatial scale talks about length, width, distance, height, things we can measure. So we're going to look at an area of 10 miles by 10 miles, or we're going to look at an area by 10 blocks by 10 blocks, or 10 inches by 10 inches. That. Temporal scale looks at time. So for instance, if you see a sunflower, it's called a sunflower because the flower actually follows the sun. We don't see it move because it moves so slow that our eyes don't perceive it. But if you put a time-lapse camera and speed it up, you see it move. So a temporal scale. Are we looking at things that are happening over 1 day, 1 week, 1 month? Think about this year and how if you were to examine this year, the scale of this year might be different than other years because of the vast amount of change that's happened. But let's look at spatial scales. So we start off with looking at the idea of sand and deserts. At a large scale, we actually look at one individual dune. So maybe we're looking at one individual sand dune. We're asking questions like, does the sand dune move? Or what type of vegetation will or will not grow in a sand dune? But if we start moving the scale out, now we're looking at several dunes, right? So we've kind of zoomed out. So the large scale is becoming smaller. And that's a contradiction. I'll talk about that in a moment. But now we're looking at many dunes. Is there a pattern? Do dunes all face the same way? As we keep on zooming out, now we look at deserts as regions. So we go from maybe 10 kilometers by maybe 10 meters by 10 kilometers by 100 kilometers. And now we notice that this desert is near an ocean. So why is this desert right next to the water? And if we zoom out even more, now we're looking at a planetary scale. And we notice, why is there a large desert here and here, right? But you notice it's funny, as we go from a large scale to a small scale, a large scale looks at a small area. And what that means is this, we'll talk about scales. A large scale looks at a small area. The scale is large. I'll show you what that means. So as we look at a larger area, the scale gets smaller. And that's because a scale is this. A scale is a function. It's a way of reducing size. So for instance, let me go back. This picture is not life-sized. We know that Africa is vast and that we would be nothing but a pixel on here. If I was to carry around a life-size map of Africa in my pocket, think about that. It couldn't fit. We have to shrink it. A scale is just the mathematical formula at which we shrink something. So in that case, 1 inch equals 500 feet. So if I drew a map, on that map, 1 inch in real life is 500 feet, or 1 inch equals 3 miles, or whatever it is. Another way of saying that is that 1 unit on the map, whatever it is, 1 inch, 1/4 inch, 1 foot, equals 6,000 of those in real life. And so that's a scale. Now, what happens is this. A small scale looks at smaller or larger areas. 1 inch equals 500 feet. If I say 1 inch equals 500 miles, that's a much smaller fraction. So, right here. 1 inch equals 500 feet. If you make that a fraction, 1 to 6,000, 1 inch equals 500 miles. Now you've got 1 to 31 million. So think about fractions. This is a smaller fraction. So just to kind of go over it again, a large scale perspective and a small scale perspective. Why would you need to use different scales? Well, a large scale perspective makes large features, makes large areas. Sorry, I gotta start over again. A large scale perspective, it kind of zooms in. If you want to look at just one sand dune or one hill or one tree, so you can see more detail, right? Whereas a small scale shows you features that overall, maybe you want to see the greater perspective. Which way do the mountains run, right? So a large scale perspective would be a cliff face or a hill, right? Small scale features would be a continent. Here's a better example. This is a large scale map of Chicago versus a small scale perspective. This small scale perspective, if you're coming from the airport to downtown, this is a great map. It tells you here's the airport and shows you how to go there. But when you get downtown, if you want to know what buildings are on what street, this doesn't really help you. But a large scale zooms in, and now you can see individual streets and even individual buildings. So really, scale is dependent upon what you're examining. The other scale is temporal, and we'll talk about that in a little bit. Spatial scales, by the way, just idea, meters to kilometers. As the units of measurement get larger, we tend to measure larger things. All right, I'm going to pause right here for temporal scale. We'll come back in just a little bit. So this is time for you to turn off this video, go get a soda or coffee or something else, and relax, stretch your feet. Think about how amazing I am as a lecturer over videos. And then we'll come back for the second video in just a bit.